Professor Richard Silverstein. I think it must be here in this audience one of the longest friendships that perhaps exists. We go back to 1960 when Richard walked into the lodge of the Melbourne Theosophical Society and I was chairing the Young Theosophists group. And of course we never parted since then. Richard took the line of science. He graduated first in Bachelor of Science in Physics, and then he went on into the neuroscience. He obviously was very much attracted with the whole psychology, the constitution of our souls, and being able to test this out scientifically. So he ended up being the Emeritus Professor at Swinburne University of Technology, and he has over 35 years of experience in this area of neuroscience research, and the originator of the steady state topography brain imaging technology. And over the years, without getting into any detail of which I'm not really familiar, he was able to develop a way of having a skull cap with being able to carefully measure brain waves and being able to help people, autistic children and others with problems in their understandings and use of the brain. So he developed this, and you might talk to him later privately about this, his medical ability to help a lot of people through his research and through his interest. Can I say that for many years he had to develop his own department at Swinburne University. Swinburne only provided him with rooms, I believe, just that's about it. But the rest of all the money, the millions of dollars he had to go out and find himself. And he was able to attract those millions of dollars of research privately for this foundation of his, for his work. And because of the nature of his work, being on the fringes, shall we say, on the fringes of accepted science, we in the Theosophy Science Group had to refer to him as Professor Anonymous. We knew that Professor Anonymous
it was Dr. Anonymous then.
Dr. Anonymous. We knew who Dr. Anonymous was, but it meant that he was sheltered from the attacks of those who would otherwise discredit him and prevent the millions of dollars of support funds coming to his worthwhile work. So we have to realize that those of us who are on the fringes of science, of acceptable science and so on, are also under some stress of walking on glass perhaps, or something, being able to, on the one hand, maintain one's position in the traditional scientific environment and being able to go beyond it as well. So I welcome Richard here. I'm so thrilled that I was able to correspond with him and ask him, but Richard, aren't you coming to our meeting? He said, oh, I'd forgotten to ask or something, so I said, please, do come along. So at the last moment, towards the last moments, he was able to enroll in this group of ours, and I'm so happy for various reasons, as you'll see, why he is here with us. So without further ado, Richard, thank you very much for your time.
Victor, thank you so much. I must say it's always an enormous pleasure participating in these meetings, and especially this one, and thank you, John, for also agreeing to a late application. I must admit this one had somehow slipped past me, and I do apologise. What Victor said earlier is in fact correct about the attitude of mainstream science, shall we call it. I have had as you can tell, a very long-standing interest in this area. In fact, it even predated my university training, etc. And my first degree, as Victor mentioned, was in physics. My main interest was theoretical physics. At the end of that, I had to make a decision what I wanted to do, and I decided that I really wanted to work in parapsychology. I was in fact one of the founding I think, actually one of the founders of two societies at Monash University. One was the Monash University Society for Parapsychological Research, and the other one was the Monash University Rationalist Society. I always like to have a foot in both camps. When I decided that I wanted to work in parapsychology, I realized that while I had a rudimentary understanding of physics, I knew nothing about the body, the brain, and if I was going to work in this area, I should at least know something about it. So that's why I decided to eventually start off with a master's in neuroscience, what was then called neurophysiology, which then became a PhD. And in nothing at all to do with the brain. I was looking at the spinal cord of the Queensland cane toad, if you must know. And I must admit that I did have to operate on them, but I did apologise to every single one of them before I did, and they didn't. And I made sure they didn't suffer. That was for my PhD. Having said that, I also realised very, very quickly that expressing an interest in parapsychology was the surest fire way of committing academic suicide. Your grants would dry up. And the interesting thing is that it depends a lot on the discipline that you're in. Interestingly, there was a survey conducted, I think is in the 90s, may have been slightly earlier, looking at the attitude of American academics to a host of questions, and one of them was the question about parapsychology. And they were given something like a 7-point scale, to answer their agreement to the following question. Do you believe parapsychological phenomena have been established, scientifically? And you could tick 7 if, yes, I'm absolutely 100% sure. 6, well, yeah, there's a lot of evidence for it, but, we're not quite there. 5, yeah, I'm probably, in other words, 3 or 4, you're in the middle, you're not really sure. Start going down to smaller numbers, maybe, but pretty unsure, to 1, which is, I know for a fact this is impossible. 1, okay? Now, what was interesting was that if you look at the response of most of the discipline, the physicists, the engineers, the chemists, etc., the proportion who answered 1, I know this is, if you'll excuse the expression, crap, impossible, was actually about 1%, 1 to 2%, very, very small. But if you look at the psychologists, and I suspect the psychiatrists, that was about, I think it was 20 to 30%. It was a huge number. In other words, that area, and my research area, was the link between cognition and brain processes. So I was working with a lot of people in that domain, and I have a theory of why psychologists are so averse to this area. I think it's related to the fact that psychology is still coming to terms with its status as a discipline, and I think it's like having that disreputable relative come to Christmas dinner. You just sort of don't want us to be seen. We're not really related to him. It's a little bit like that. Okay, so that's the background, and that's why I happen to be here, and why also it gives me so much pleasure. So my apologies for the rambling introduction. One of the perennial topics that I have been exploring is the etheric body, and a new age fantasy or a revolution in biology. What I'm going to be presenting is some very, very recent scientific research. By recent, some of the papers have been published in 2016. And a lot of them will be based on the work of, I think, one of the most brilliant developmental biologists, a bloke called Michael Levin at Tufts University in the United States, who is doing, I think, some absolutely amazing work, and I'll this will be an important part of the talk. If we go to the Theosophical literature, and probably the person who summarised some of the Theosophical literature, E.R. Powell, based on the writings of various authors, Leadbeater, Blavatsky, etc. Basically, the etheric body is claimed to be a physical structure entity, and that it plays an important part in determining the kind of physical vehicle which an incarnating ego will receive. That, like the physical body, it dies and decays and in due course releases the soul, etc. So the important point is that the etheric body is a physical entity, and it has two main functions, and let me just read them to you, and I apologise for that. Firstly, it absorbs prana or vitality and distributes this to the whole system. Interestingly enough, the first talk I gave as national speaker, where my name was published rather than Dr. Anonymous, was on what might be, is there a physical correlate to prana? And I was speculating on the role of negative ions in the air as possible sources. So first, it absorbs prana vitality and distributes the whole body. Secondly, and I've got this underlined, it acts as an intermediary or bridge between the dense physical body and the astral body, transmitting the consciousness of physical sense contacts through the etheric brain, that's the quote there, to the astral body, and also transmitting consciousness from the astral and higher levels down to the physical brain and nervous system. So the idea here is an intermediary structure, a transducer, and that's sort of where, in a sense, I had sort of started from in terms of the theosophical concepts of the etheric body. Now, I think many concepts like the etheric body, the astral body, various other concepts possibly have multiple meanings, levels of meaning. And what I'm going to talk about is one aspect of that, and that's not just to deny that there may be others as well, okay? So first of all, let me just briefly say what I'm not going to talk about, which has been referred to. One is Kirlian photography, or essentially coronal discharge or high voltage photography. This undoubtedly says something. Precisely what it does say, I'm not altogether sure, but nevertheless, it may be an aspect, but that's not what I'm going to talk about. Okay, so that's the first one. The other one, the so-called killer screen. This is the one where it's a sort of a purplish-like screen. If you look through and you look carefully, you'll see a sort of an outline around people and things. People have speculated that's a manifestation of the etheric body, and it might actually in some way enhance people's perception, but there's also a rather physical interpretation of that haze around the person, and that is because purple is an interesting colour. Purple is actually a mixture of red and blue, and the fact of the matter is that the eye, the lens of the eye, can't bring into focus those two ends of the spectrum simultaneously. If the red is in focus, the blue is not in focus. And if the blue is in focus, the red is not in focus. So what do you see? You see a haze, which is basically the thing that's out of focus. So I'm sorry to disappoint anybody who loves killer screens, but that's one. So let's have a look, nevertheless, at what subtle energy systems there may be which could act as this sort of transducer. And I'm going to start off with a bit of some chemistry and physiology, and I apologise, because we're going to be looking at bioelectric fields. So because I think these are an important element in the story. So how do bodies create electric fields? If we start off with salt, just common salt, could be anything, it's neutral. It has no charge. However, if you look at the atoms which make up the salt, the sodium chloride molecules, they comprise sodium atoms and chlorine atoms. Now the point is that each of those atoms on their own are neutral as well. The number of electrons and protons are the same in both cases. But when they form a chemical bond, what happens is the sodium donates an electron to the chlorine. The chlorine then becomes more negative because there are more electrons and protons, and the sodium becomes more positive because there are fewer electrons and than protons, and then they more or less bind together because of the electrostatic forces. Now, that's when they're a solid, but when they go into solution, into water, what's happening now is the chloride with the negative charge of the chloride ions can move around freely, and so can the sodium ions. And so that water with a bit of salt in it is still completely neutral. Now, this is meant to represent a cell, and inside the cell I've just got, instead of sodium, which is symbol Na, I've got potassium, because the inside of the cell tends to have more potassium. Potassium chloride, that blue is meant to represent water, and the circle is meant to represent the membrane. I don't know if you can see, can you see that red dot? Oh, okay, right. So that's meant to represent the membrane of the cell. Now these funny little lines here are what are known as channels. These are, if you will, special channels within the membrane that just allow one sort of ion through, but not another. And this particular one here only allows the potassium ions to go through, but not chloride. And this can happen because, in a sense, the size of the ions, the amount of water on them, will vary. Now, if you've got the outside of the cell has got just water, no chloride, no potassium, what will tend to happen is those potassium and chloride ions, they're not stationary, they're moving around all the time. And I'm just using a very simple classical interpretation of what's happening. They're moving around, and if a chloride ion happens to be near this channel, it'll be able to pop out just by random. And as I said, it's moving randomly. And as was pointed out by a photon created in the center of the sun, when it's created, it more or less is absorbed, and it just moves around almost by Brownian motion. And eventually, it takes apparently up to 1 million years to eventually get to the surface of the sun. Now, there are same sort of Brownian motion of these potassium ions, and what happens is some of the potassium ions happen to be around here, and they happen to pop out this way, and because their movement is completely random, you'll tend to get a net flow of ions coming out, which we call diffusion. But that's all it is. It's just the statistical flow, nothing else. Now, the fact that potassium has gone out, but not chloride, means that now you've got more negative charges inside because there are more chloride than there are potassium. And so now you've got an electric field across the membrane simply because of allowing potassium to go through but not chloride. It's as simple as that. Now, obviously in real cells there's sodium, there's other ions, etc. But that's the basic principle. That's how cells make electricity. And you can measure the difference between the inside and the outside, and it's about, for a nerve cell, it's about minus 70 millivolts, or 70 thousandths of a volt. These days you can also, and this is called the resting membrane potential. That's all it is. Now you can also measure the voltage across a cell membrane using now these things called voltage sensitive dyes. These are dyes whose change colour depending on the voltage. Okay, now I appreciate you've been extraordinarily patient. This is rather boring stuff, but we just need to get through this. Okay, so that's how cells create a resting membrane voltage electricity. Is this useful? Well, yes, it is, because nerve cells and muscle cells experience these sudden changes in voltage, which are due to rapid changes in these channels. Sometimes they'll allow sodium to come in, and suddenly the inside becomes now less negative, goes up, and you have these things called action potentials or nerve impulses, and they can travel. Nerves, muscles, all sorts of muscles, cardiac muscle, smooth muscle, skeletal muscle, all of these do the same thing. So the resting membrane potential is important because it's a means of communicating nerve impulses down a nerve. We all know that. It's known for about 150 years, no big deal. But the fact is, most cells don't have these big changes which are called action potentials. So is the resting membrane potential of any relevance beyond that? Most scientists would have said, yeah, it's there, but it's no big deal. It just happens to be one of those epiphenomena, something that occurs but has no real significance. Well, is that the case? As I said, but the overwhelming majority of non-excitable skeletons, is the resting membrane potential of any significance? Maybe. Now, what you can't see here, and I do apologise, is this is a graph. Down here, minus 90 millivolts, that's the most negative that cells typically can get, and 0. And what you find is, and I'll have to sort of read this for you, is the more negative the inside of the cell is, the stronger the resting membrane potential, the less likely that cell is to reproduce, to split off and create other cells. So, for example, the cells which don't reproduce, skeletal, muscle, neurons, etc., they've got the strongest one. Liver is at minus 35 millivolts, but liver can replicate. And cells like fertilized eggs, they're sitting at about 3 or 4 millivolts, in other words, a fraction. And interestingly, cancer cells, they're all sitting at around minus 40, 30, minus 10. In other words, the resting membrane potential seems to be associated with the cell's ability to reproduce and replicate, both for good or ill. Cancers, not so good. So that's interesting, but is the resting membrane potential, I'll just read this, simply an indication of the cell's capacity to proliferate? In other words, it's just a measure, a little marker, or does it actually mean more than that? And now what I'm going to do is quote some of the work of Mike Levin, because what he has found, and this is a bit messy, but what he has found is this, that the resting membrane potential is actually more powerful than some of the genetics inside the cell. What this slide shows is they've taken, these are tadpoles which they tend to work on, and what they've done is you can take a gene which causes the cell to become cancerous. And when you put that gene inside the cell, basically a cancer develops. Now, what they showed was that using a whole lot of different ways to achieve the same goal, they changed the resting membrane potential of that cell and made it more negative. In other words, more like a cell that doesn't reproduce. Now, what happened? Two things. First of all, the gene which said make this cell cancerous was still doing its thing inside, but the cell now behaved as a completely normal cell. In other words, the resting membrane potential had turned off the capacity of the gene to turn that cell into a cancerous cell. In other words, the resting membrane potential seems to be a controlling factor rather than just simply an epiphenomenon that's sort of turned up. Now, that's what happens across cells, and in fact he's shown us at a number of studies that the resting membrane potential is a really important guide telling cells what to do. Now, the other point to note is this, that these cells with these resting membrane potentials, when they're part of your body, they make contact with each other, and these contacts, this here, are like what are called tight junctions, which basically means it's a bit like having a wire or a short circuit between the two cells. Now, what that means is that if I've got two batteries, and they're both exactly 1.5 volts, and they're in parallel, and I join them by a wire, if they're both exactly the same voltage, they'll be opposing each other and nothing will happen. However, if one is 1.5 volts and the other one is only 1 volt, now you'll have a flow of current. And what's happening is that when you've got two cells and one has got a resting membrane potential of minus 70 and the other one minus 69 millivolts, and they're in contact, now you'll have a flow of current. And that flow of current creates bioelectric fields. Now, this is simply a view of the bottom part, the ventral part of a tadpole, where the voltage is given by the colour. So, for example, the more depolarised, the less negative inside, shows up as warmer colours, red, and the more polarised, more negative inside, shows up as deep blue. So what you've got is, if you look at this structure, you'll find that there is this structure, this bioelectric structure existing over the whole body of the organism. And this doesn't just apply to tadpoles, it applies to almost every living thing that we have. Now, they're pretty, as I said, pretty picture, but are bioelectric fields simply irrelevant to the task of building a body, creating a body? And some of the work that I'm going to show you, as I said, is biological work, developmental biology, and so it will involve animals such as what are known as little flatworms, Planaria. These are worms that reproduce by splitting themselves, or tadpoles. So they're the animals that are used. Okay, so let's just have a look. What I'm going to show you here is a time-lapse movie of two, these are blastocysts. In other words, these are frog eggs, fertilized frog eggs that are splitting and will eventually become a tadpole. But what I'm going to show you is time-lapse photography, and the warmer the color that you'll see on the surface there represents more depolarization, more electric field in that region. Does the electric field guide the development of the tadpole? So I want you to look at, particularly at this one here. It starts off warm because there's all these proliferation and new cells being created. But watch what happens. I'll give you a hint as to when. So here's the movie. This is the cell I want you to concentrate on. Okay, now you notice there's this burst of, just a minute. There, see that burst there? Now watch what happens to it. That, long before you see anything under the microscope, that is in fact the instruction to say, build a face. I don't know if you can see that. I hope you could. I apologize if it's... Anyway, the point is that there is evidence that these bioelectric fields play a crucial part in the development of the entire organism. It's not just a matter of genes and cells. So, for example, if you take a fertilized egg, if it was all just simply each cell knowing what it has to do on the basis of what its neighbour is doing, if you split it, you should have two half people being born, but you don't. You end up with identical twins being born. And similarly, if you take two fertilized eggs and you fuse them together, instead of creating, two half things, you in fact have one animal, but it's got two genetic makeups. So one of the animals that Mike Levin's lab works on a lot is what are known as the Planaria. These are little flatworms, and they have this, the way they reproduce is they split. I don't know if there are many other, well, obviously single cells split to reproduce, but I don't know if there are many other organisms that do it that way. So what tends to happen is that if you make a cut in this, the head eventually grows a new tail, and the tail eventually grows a new head. And the interesting thing is that if you make more than one cut, like a cut here, a cut here, a cut here, they all seem to know where they come from. So this little head here eventually develops a tail. This middle part here, the front part develops a head, the back part develops a tail, etc. It's a little bit like cutting a magnet. You always get north-south, north-south, north-south. Are bioelectric fields of any relevance here? And it seems that it's the bioelectric fields that tell the organism this is where the head is, this is where the tail is, etc. Because what Mike has done is, using a variety of different methods, he has switched off the bioelectric field in the middle, for example. And what you end up with, is basically a planaria with two heads. Now, and every time they split and grow normally, the offspring will also have two heads. They do have something they can excrete with as well. But the point is that this is now going on in perpetuity, and it's the bioelectric field which governs how that body development is to take place. And it goes beyond that. As what Mike and his group have shown is that by making a change to the bioelectric field, for example, you can give the instruction, make an eye. For example, in a part of the tadpole, which normally would not have an eye, so you can have what are called ectopic eyes. So it looks like it's the bioelectric field which is controlling the growth and development of the organism. And there's some very, very interesting work that suggests that these bioelectric fields can also preserve memory. And this is a paper published 2013. And what they did was you can train Planaria to look for food in a particular place in a dish. Relatively straightforward. Now, the Planaria, they have a brain, etc. And, they have eyes and a brain, etc. Now, what you can then do is you can cut the Planaria in half, which is, as I said, the way they normally reproduce. And then just look at the tail. The head go on to develop a tail, but they're not part of the study. Just look at the tail, which has no brain. It just has some residual sensory nerves, but that's about all. And it will eventually grow a brain. But here's the amazing part. The new brain has the memory of where the food is that was taught in the original one here, suggesting that memory, even for such things as memory for food, is stored in a distributed fashion involving these bioelectric fields. So what Mike and his group have suggested is this. The fundamental philosophy, dogma in biology, is that all development occurs starting with the genetic code, or what's known as the epigenetic code. The genetic code is the basic DNA structure, and it controls everything. So epigenetics is simply experiences that have occurred, the environment it has influenced the animals or the parents, and certain genes are, for example, switched off or down, and other genes are increased, and those increased activity genes and decreased activity genes are passed on to future generations, and in fact for a number of generations, and that's called epigenesis, and it's an important discovery. But all of these are, if you will, what are referred to as bottom-up. What Mike and his crowd have shown, and they're beginning to be others, is that bioelectric field structures play a crucial role in the organisation of and the growth of the organism. And in fact, one of these areas is not just the development of the organism, but what's called regenerative biology. So the question that was asked earlier on, why don't scientists do something that's a bit more useful, such as regrowing limbs? That's in fact exactly what he is working on, of how you can actually regrow limbs. I thought I'd just mention that thing. But this notion of these top-down processes being important, it is hard to understand how developmental biologists find this, many of them find this anathema. This can't be the case. And yet it is, and it's a very important organisational principle. So that's, by the way, and that paper was published in 2016, where that illustration. So let it not be said, I serve up old stuff. Now, let's move on to the link and the relevance here. Ian Stevenson has been mentioned. He and his co-workers have probably done a lot to essentially establish evidence for reincarnation. Certainly, the transfer of memories, and not just memories in an abstract sense, but what are known as autobiographical memories. People feel that this was me, and certain things happened to them. And what I'd like to do now is to discuss the link between bioelectric fields and past life memories. There's a bit of a leap for you. Now, as was pointed out, but in Ian's book, children claiming past life memories are most likely to have described themselves in previous lives as a child or young adult experiencing a violent death with a relatively short period between death and subsequent rebirth. That tends to be, not always the case, but invariably tends to be the most common. One of Stevenson's particular interests was, in brackets, because he died, I don't know how many years ago, is the relationship between the location and nature of birthmarks and the manner in which the previous life ended. So, for example, here's one case of a person who claims to have died as a result of a bullet, a gunshot. The post-mortem indicated that that the entry point was here and the exit point was there, and this is a post-mortem study, and the person who claimed that memory in fact had a birthmark both at the entry and exit point of that. Now, that in itself does not constitute proof. Please understand that. The proof comes from the accuracy of the claimed memories and attempting to sort of determine that. Now, I would say that the proof of reincarnation, while there, is not yet as robust as, for example, telepathy or even telekinesis, or even precognition. Nevertheless, it is there. There's a considerable body of evidence, and I must admit, I for one find it compelling. But that's just me. So the point I'm making, given the central role of bioelectric fields in the developmental process, is it not unreasonable to suggest that disturbances to the bioelectric field pattern during fetal development gave rise to these birthmarks? This suggests that previous life events influenced the bioelectric field development blueprint via the influence of the incarnating entity. I'm not suggesting that the bioelectric field pattern of the person who's died is somehow replicable. What I'm suggesting is the bioelectric field is the means by which the incoming entity may influence the vehicle, the body, which it is ultimately to inhabit, for lack of a better term. Now, if in fact, because as I pointed out to you, these bioelectric field structures seem to be the dominant factors influencing how bodies develop. Like I said, in the case of those tadpoles, you could literally, given instructions through the bioelectric field, create an eye in locations where there are meant to be no, and these eyes, by the way, actually work. They send nerves to the brain, etc. Now, I know it sounds a little bit gory and bizarre, but what it's doing is it's demonstrating the fact that these bioelectric field structures have an enormously powerful, significant role in development and regeneration. So if they can do this with essentially the body, why not the brain? And by the way, it's not necessarily even the actual experience. There is, in the Eastern tradition, there is a practice in some case to help recognizing the incoming person again they will put marks, chalk marks, soot, etc., on parts of the body and look for a birthmark in that location. In other words, the person's already died. You're putting the mark on the body, so for example, in this case on the leg, and looking for it. Now, this is nowhere near as well validated even as the reincarnation memories. But what it suggests is that if the entity that has left that body is nevertheless aware of what has happened, via the bioelectric field patterns of its incoming body, it can influence even the development of such things as the birthmark. Now, if it can influence these bodily structures, why stop at the body? Why not, for example, the brain, and changes in the microsynaptic structure are very... If past life memories can be recalled, then they are also represented in the brain as specific network of synaptic changes, most likely in a region of the brain known as the hippocampus. Now, what I'm referring to here is past life memories or memories that can be recalled. If I were to ask you, how did you enjoy, what happened during your last birthday or think of a particular day, those memories, your ability to be able to express them and to recall them is determined by the integrity of the neuronal networks within the brain and the synaptic patterns that were created. Now, I happen to believe that those memories exist at many different levels, but there is a physical brain level at which they exist, which needs to be appropriately functioning for you to be able to recall them. I think there are other levels, even extending to the so-called Akashic record, where these memories, this information continues to exist. But if you're able to recall, what you did on your birthday, what you had for breakfast this morning, etc., it depends on the integrity of these neural networks. Now, so if they're able to make these recollections, it's because these networks have changed, and I would argue that it's the incoming entity via these bioelectric field structures, which now sound very similar to what E.R. Powell said about one of the functions of the etheric body, the means by which the incoming ego influences the development of the incoming the vehicle to be occupied. Changes in the brain up at the region of the hippocampus, cortical synaptic connections necessary for the manifestation of past life memories is most likely mediated by modification of brain bioelectric fields controlling development. And this may happen prior to birth and in the third trimester and during the period following birth. So that's where I'd suggest these are likely to have occurred. Now, what is interesting is past life memories appear to fade. And typically from after about the age of 4 or 5, there are obviously notable exceptions, but they do appear to fade. Now, interestingly, this early period where past life memories can be retrieved corresponds to a duration, what is known as neonatal amnesia. There is an interesting phenomenon that at about the age of 3, 4, or 5 or thereabouts, people have great difficulty recollecting, remembering what happened before. Now, if you take, and it's not just a matter of the amount of time that's elapsed, because if you take, for example, a 3-year-old, they can remember what happened 2 years previously, but then when they become 4 or 5, that 2-year gap, which seems to have crossed the neonatal amnesia period, they lose the ability to remember and recall what they were able to recall earlier on. And this phenomenon is known as neonatal amnesia. And as I said, do these changes bring the curtain down on past life memories so that we can engage in the challenges and lessons and opportunities that this life has to offer. Now, interestingly enough, people have been looking at what is the mechanism behind neonatal amnesia. And because apparently there is a similar phenomenon in animals as well. And the hippocampus, this region here, which is part of the temporal lobes, is a crucial region for storing memories, particularly in the early stages. Those memories are then distributed in other parts of the brain. But the hippocampus plays a very important part for a long time in being what you could think of in computer terms, the lookup table. It tells you where to go in the cortex to retrieve particular memories. And in dementia, for example, it's the hippocampus, which is the first region to suffer. And by the way, you know something that really, really simple, which reverses, which can help with the normal atrophy and shrinkage of the hippocampus, which occurs, I'm afraid to tell you, from about the age of 50 onwards at about between 1% and 2% a year. There was a fascinating study published in the Proceedings of the National Academy of Science in 2011, where they took two groups of people, same age range, and they used MRI to measure the volume of the part of the hippocampus that shrank, and they gave them two sets of exercise. One group did some stretching and strengthening exercises on 2 or 3 times a week, 3 times a week. The other group simply walked 25, 30 minutes, 3, 4 times a week. And relatively modest walking, you know, heart rate up 50 to 60% of maximum, which is very, very modest, I might add. What they found was that the group that did the strengthening exercises, there was a negligible improvement. That the rate of shrinkage seemed to have dropped slightly, but not much. It was still between 1% and 2% per year. The group that had just done the walking, not only had there been no shrinkage, it had actually increased in size, and their cognitive ability seemed to have also increased slightly. So something as simple as walking on a regular basis does good things for your hippocampus. Make sure that goes into your hippocampus now and you remember it, because I think it's useful. So what seems to be happening with neonatal amnesia appears to be related to new cells being generated in the hippocampus. And new cells are being generated all the time, in all of us now. It's the rate. And so does that mean the memories are gone altogether? Well, no. There is evidence that the memories continue, but we're not conscious of them. And this briefly brings me to just a sort of a classification of memory processes. In psychology, memory or long-term memory can be divided into short-term memory, we won't talk about that, and long-term memory. The long-term memory can be divided into conscious memories and what are known as implicit memories, or so-called unconscious memories. Now, you can go further. The explicit or conscious memories can be divided into what are known as episodic memories, events, etc., and they can be, they're personal events, I should say, things that happen to me, or they can be semantic memory about facts, etc., whereas the unconscious memories, they involve things like procedural memory, things like riding a bike. Can you ride a bike or not, etc. But there are also, if you will, what's called sometimes priming, how one event or a stimulus can cause a reaction because it's associated with something that you can't recall, but it's there. So these, if you will, unconscious memories. Now, what I'm suggesting is that past life memories are not generally, they can be episodic, in other words, these experiences happen to me, but I would argue most of past life memories are of the unconscious kind, implicit memories, and that in fact that past life memories are actually much more present in our lives than we imagine, simply because we cannot recall specific events and scenes and things like that, but your emotional reaction to things, etc. These unconscious processes, these, I believe, are powerfully influenced by past life events, and they act there as implicit or unconscious memories. So in conclusion, recent scientific discoveries have revealed that the crucial role of bioelectric fields in the development and health of living systems. Such discoveries, I believe, will revolutionize our understanding of biology and medicine, in that it introduces bioelectric top-down processes to complement the better-known bottom-up genetic and epigenetic mechanism. And it's suggested that bioelectric fields constitute an information storage or memory system guiding the development and health of the body. In addition, it is suggested that bioelectric fields modulate the development of prenatal and neonatal birth synaptic connectivity that makes possible the manifestation of explicit and implicit past life memories. So in conclusion, long-standing theosophical literature proposing the existence of a subtle physical, quote, etheric body that influences the development and health of the physical body, as well as acting as a link or transducer to more subtle levels of existence, has in part been validated. Thank you.